Hi. So today we're going to do topic 2, laws of logarithms. So we're going to learn the logarithmic laws. Super fun. It's a nice tool for us to use. So we're going to develop. Now I know what I did. I accidentally. There we go. Let's see if we get it going again. All righty. Cool. Touch my keyboard. There we go. So we're going to develop the laws of logarithms and use these laws to help us simplify logarithmic expressions. They are connected to our exponent laws, right? Now we know we have these laws called exponent laws that help us simplify or evaluate powers. Well, logarithmic laws also can help us simplify and evaluate logarithms. So we're going to start with a little exploration. We're going to use our calculator and we're going to evaluate each of these. So if I have log 6 plus log 5, enter, I get equals 1.477 71. There we go. It says to the 10,000. Okay, so I can get rid of the rest of this. Okay, now if I evaluate log of 30, voila, I get exactly the same number. 1.4771. Okay, now based on those results, we can suggest a possible law for log m plus log n, where m and n are positive real numbers. Well, what we can see is 6 and 5, if we multiply them, we get 30. So we could, our proposed law is that log m plus log n is equal to log m times n. And this is related to our exponent law, x to the m times x to the n equals x to the m plus n. Okay, so that's kind of the connection there, because exponents and logs are related. So if we look at that, we have log 100 plus log 10, that would be the same as log 1,000. We multiply those two, which is equal to 3. Let's just test that out. 1. Boom, 3. Okay. Now let's look at subtracting. So we have log of 35 minus log of 5. And we get 0.84509, which rounds up to 10. Okay. Now let's look at log of 7. Well, I get the same number, 0.84510. I'm rounded up, right? Now here we have a subtraction situation. So based on that, we're going to propose a law for log m minus log n. So log m minus log n is equal to log m divided by n. Woo! And this relates to x of m over x of n is equal to x m minus n. Okay? Now we're going to use our law to express log 1,000 minus log 10. Well, that would be log 100, because we would divide 1,000 by 10, and that equals 2. Log of 100 equals 2. Okay? We're not done. We're expanding and we're developing log laws. Use a calculator to find the approximate value of each of the following. 2 log 7. Well, that equals 1.69019 and log of 49. Why? It's the same number. Now, think about this. We have a 2 and a 7. 7 squared equals 49. So there's our connection between these numbers. So based on those results, we're going to suggest a possible law for p log m, where m is a positive real numbers and p is any real numbers. So p log m is equal to log MP. All right? Just basically put, if we looked at first one, 7 to the power of 2. Okay? We can use this to express 2 log 10 as a single logarithm. 2 log 10, therefore, would be log 10 to the 2, which is log 100, which equals 2. Okay? The laws for common logarithms are also true for any logarithm with a base that is a positive real number other than 1. We're going to use these logs to simplify and then evaluate. So let's look at what we have here. Here we have log 618 plus log 62. Okay, so that would be log 618 times 2. So log 6 of 36, right? Now to evaluate that, well, it's 6 to the x equals 36, so x would equal 2, right? Okay. Log 2, we've got here, let's just see, we've got a subtraction, so we're going to divide. So it'll be 40 over 5. So it'll be log 2 of 8. And now we're going to evaluate that. Well, sorry, 2 to the x equals 8, so x equals 3. Because 2 times 2 times 2 equals 8. Okay? You can also use your log rules for evaluating. Log of 8 divided by log of 2 will also get you 3. 4 log 9, 3. So this is the same as log of 9, 3 to the power of 4. Oops, that's a 4. So log of 9, 3 to the power of 4 equals 81, right? So evaluating, 9 to the x equals 81, so x equals 2. Okay, pretty cool. Now, here we've got a summarization. Now this table is going to come back at the end in your need to know, but it's a very, very handy table. So I would suggest you mark it. We've got our product rule where we're multiplying it, because we're adding 2 logs with the same base and then we multiply them will be equivalent. Quotient, subtracting and dividing, right? If we subtract 2 logs with the same base, we can also divide those to solve. And then we have the power rule. So if we have a factor on the outside, we can change that to a power to help us evaluate. So this is kind of a summary of these laws that we just learned. Now it's easier to learn things, I find, by doing practice. So we're going to practice and they're going to get a little more complicated. But we just follow our steps. We also think about BEDMAS when we're doing these. Think about brackets. I always say more brackets are better than none. Okay, so let's look at this first one. We're subtracting. So subtracting means that we're going to divide. So it's going to be log 550 over 2. So log 525. So to evaluate, that means 5 to the x equals 25. So x equals 2. Cool, hey? Here we are adding. Adding means we multiply. So log 3, 18 times 3 over 2. So log 3 of 18 times 3 over 2 is 27. So to evaluate, 3 to the x equals 27, so x equals 3. I'm just going to square my solutions, put a box on them. I would say put a box around and give them a present. Now here, we have this factor here, so that means we're going to change it to a power. So it'll be log 4 of 2 to the power of 4. So log 4 of 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16, right? So to evaluate, 4 to the x equals 16, so x equals 2. Okay. Making more sense? We're going to do more. We are definitely going to do more. Okay? I just got to get the right pages going. Okay, here we go. Page 24. So sometimes we might have more than one thing to do. We have to use multiple logarithmic laws. So you're going to want to deal with BEDMAS. So we're going to deal with the fact that we have an exponent out here first, but we also are adding. But we're going to deal with this one first. So this would be log 3, 6 to the power of 2 plus log 3, 0.75. Excuse me, 6 to the power of 2 is 36 plus log 3, 0.75. Now, because we're adding, we're going to multiply those two. Log 3, 36 times 0.75, right? So it'll be log 3 of 36 times 0.75 is 27. So thinking about this, I'm going to do it in a different color so we can see it. So it's 3 to the x equals 27, so x would equal 3, right? Okay. I took up a little extra room there. Okay. Next one, again, we're going to deal with the exponent first. We're going to remember our BEDMAS. So we're going to have log 540 minus log 5 2 to the 3, right? We make it a power. Okay, just like here we made this a power. So log 540 minus log 5 2 to the power of 3 is 8. So now we're going to, because we're subtracting, right? We're going to divide. So log 540 over 8. So that's log 5 of 5. Well, 5 to the x equals 5, so x has to equal 1. Okay. Alrighty. Now here we have two. We have an addition and a subtraction. We're going to do the addition first. Just like BEDMAS, we're going to go left to right. Okay? Because just that's how BEDMAS will work, right? So first we're going to multiply. So it'll be log 6, 8 times 9 minus log 6, 2. So this will be log 6 of 72 minus log 6 of 2. Now we're going to divide. Log 6 of 72 over 2. So log 6, 72 divided by 2 is 36. So to solve that, 6 to the x equals 36. So x equals 2. So 6 times 6 equals 36. So just take your time, do your BEDMAS. We can also go other directions. This is just some practice in manipulating using logarithmic laws to express as a single logarithm. So here it's just thinking about what that does. This will become log 2x to the 3. That's all we had to do there. Here, this is the same as having 1/2 times log 3x. So it would be log 3x to the 1/2. Okay, so you might just want to rewrite it so that you can express it differently. We haven't talked too much about natural logs, but they work the same way, and we can apply the logs the same way. It's just we're dealing with natural logs. So here, the first one, we're going to have ln x to the 2 minus ln y. And then we're subtracting, so we're going to divide. So it'll be ln x squared over y. You might want to put a bracket around just so that it's clear what is in the argument there. Okay. Here again, we're going to do each term separately and then combine. So this would be log x to the 3 minus log y to the 1/3. Now it's a subtraction, so we're going to divide. So it will be log x to the 3 over y to the 1/3. And again, brackets are handy just to kind of sort out what's going on. Using logarithm to expand expressions. So sometimes you might have to expand them backwards. This is practice. So we're going to expand this backwards. So this is the same as 6 ln x. Okay. Looking at this one, we're dividing. So it's going to be log 7 of 1. Dividing means we're going to subtract. So it'll be log 7 of x squared, right? Log 7 of 1, the interesting thing is log 7 of 1 is equal to 0, right? Because 7 to the x equals 1. The only thing x could be to give you a 1 is 0, right? So minus, now we're going to move this 2 over, 2 log 7x. So it would be negative 2 log 7x. We can lose the 0 in front as long as we have the negative sign there. Okay. Oops. I see a whole bunch of other stuff there. We're not done. We are close to done, but not done. And here we have log 5xy over z. So we would, first of all, I would do the subtraction, not the multiplication, because you want to separate those. So it'll be log 5xy minus log 5z. Now I can deal with the multiplication. So log 5x plus log 5y minus log 5z. Okay, and you can put brackets or not, and this is just going the other direction. It's important to note we can express logarithms in lots of different ways. And this is good to know because it's going to affect how you solve things. So we're going to express log 8 in 3 different logarithmic forms. First, we could express it as a sum of logs. So remember, to get a sum of logs, it's the multiplication factor, right? So we need to think of 2 things that multiply to give us 8. First ones I think of are 2 and 4. So log 2 plus log 4. Okay? We can also use a difference of logs. So you want to think of, well, what's a division question that will give me 8 as a result? Well, I could do log 16 minus log 2. I could also go log 40 minus log 5. Both will give me log 8 because it's 16 divided by 2 is 8, 40 divided by 5 is 8. And then using the product of an integer and a logarithm. So if you think about how we can express 8 as a power, well, it's the same as 2 to the power of 3. So log 8 would be the same as 3 log 2. Because if you rearrange this, this would be log 2 to the power of 3, which is equal to log of 8. Okay? So you have to think a little bit about the exponents that are involved. All right. Now, this need to know, kind of went through it. This summarizes all your log laws. Keep this handy while you work through things, because hopefully eventually it becomes second nature and natural, but you're learning, so it's new. So it's basically talking about those 3 log laws and the fact that we can rearrange them. And they are based on the exponent laws, or they're connected. The way they work are connected to exponent laws, but they are a little bit different. But there is a relationship there. Okay? Alrighty.